Good morning, dear students. Now today we will come to the last portion of this chapter. We'll solve some numericals from the book also. From the book, 3 numericals are there. Then also the numericals which I have sent you in the last class. There are few numericals, 5 numericals I have sent you. So I'll tell you how to I'll solve it, how to explain the numericals. So before we come to the numericals of this chapter, I'll tell you about the term power. Now power is defined as the rate of doing work. Rate of doing work means power is defined as the rate of doing work. Rate of doing work means work done divided by time. Okay, so rate of doing work means a time. In how much time you will do a work, that we consider as a power. And the SI unit of power is watt. W-A-T-T. SI unit of power is watt. Okay, so to calculate power, you will use the formula W divided by T, work done divided by time. To calculate work done, W equals to F into S, one formula, and other formula is also there. When the body is raised to a height, then you calculate the work done by using a relation mgh, that is mass into acceleration due to gravity into height. So these are the 3 formulas you should remember when you solve the numericals. Okay. Now the first numerical is you have to calculate the force in which 300 joule of work is done. Okay. Now the work done is given 300 joule, and the body will produce a displacement of 5 meter. Then you have to calculate force. Now to calculate force, you will use the formula W equals to F into S. So W means it is given 300. Force is given here. For force, you have to calculate. Then distance is given here 5. Now force equals to 300 divided by 5. 5 ones are 5. 5 6 are 30 and 0 will come. Force equals to 60 Newton, which is very easy. Second one is also there. Work done is given. You please refer page number 69 for the numericals. Okay. So question number 2 is there. Work is also given 36,000 joule. Force is given 6,000 Newton. You have to calculate the displacement or distance. So W equals to F into S. So W, you just substitute the value here, 36,000, 6,000 into S. So S we calculate is 36,000 divided by 6,000. 3 zeros are the numerator as well as the denominator cancels here. 6 ones are 6, then 6 is at 36. S equals to 6 meter. Similarly, question number 3. Now this question number 3 is a little bit different. It is related with the 2 persons here, Pallavi and Parul, and you have to calculate the work done, okay, and the ratio of power. You have to calculate both the work done as well as the power, and power you have to find in ratio. So first of all, I have written here Pallavi and Parul. So the mass of both Pallavi and Parul are same. Please refer the question. Okay, in a question it is given both Pallavi and Parul are having their same mass. They are lifting the same mass here. Then height equals to 50 centimeter. Okay, now convert this centimeter into meter. Why you are converting into meter means because the mass is given in SI unit. You have to convert that height or distance also in SI unit, because centimeter is the CGS unit. So convert that centimeter into meter. 50 divided by 100, 0 cancels. 5 divided by 10 will be 0.5 meter. Here also mass is same. Height is also same. Parul is whatever the body has been lifted by Parul is also same. Height is also same. Okay, and time for Pallavi is 2 seconds and time for Parul is 5 seconds. Okay, now you have to find work done. You cannot use this formula W equals to F into S. Since the body is raised to a height, okay, in that case, to find the work done, you use the relation W equals to M into G into H2. Please remember that when the body is on the surface, then only you will use the formula W equals to F into S to find the work done. But when the body is raised to a height, instead of using W equals to F into S, you will use the relation W equals to M into Z into H. So in both the cases, you have to calculate the work done. So W equals to M into Z into H. Here also M into Z into H. Substitute the value. Mass is 20. Acceleration due to gravity. We have to put 10 meter per second square, which is given in the equation. Then height equals to 0.5. Then when you cancel it here, 10 into, remove the decimal, 5 over 10, 10 cancels here. So 20 into 5 will be 100 joule. Similarly, here also the work done will be 100 joule. Now you will calculate the ratio of the power. Okay, now we will calculate the power. Now the next one, you have to calculate the power of Pallavi and Paru. Now power, to calculate power, you will use the formula P equals to W divided by T in both the cases here. So work done we have calculated for Paru and Pallavi 100 joule, that is same. Now but the time taken are different. Time taken for Pallavi is 2 seconds, time taken for Paru is 5 seconds. So therefore P equals to 100 divided by 2, here also 100 divided by 5. Since work done divided by time, work done is 100 joule. Now cancel here, 2 ones are 2, 2 50s are 100, 5 ones are 5, 5 20s are 100. So power equals to 50 watt. Here power of power is 20 watt. Now you have to calculate the ratio. So to calculate the ratio, power equals to 50 divided by 20. So 0 0 cancels here, equals to 5:2. So 5:2 is the ratio, ratio of the power, okay, of Pallavi and Paru. Okay. Now the next one is, day before yesterday I have sent you the numericals, which is not in your book. Okay, I have given my own own questions. So today we will solve this also. Okay, the first question is like this: we have to calculate the kinetic energy of a body, and that body is moving with a velocity of 0.2 meter per second. Okay, you have to calculate kinetic energy. So to calculate kinetic energy, I have told you that the formula is here. Kinetic energy equals to half mv square. So half into mass is 2 and velocity 0.2 whole square. So half into 2 into 0.2 whole square means 2 times 0.2. So 0.2 into 0.2. Then half into 2 into, remove the decimal, 2 upon 10, here also into 2 upon 10. So 2 cancels here, 2 2s are 4 divided by 10 into 10, 100. So 1 2 decimals are there. Okay, 1 2 zeros are there. So after 2 zeros, you will put the decimal. So therefore 0.04 joule will be the kinetic energy. Okay. Now the next question is, you have to calculate the velocity. So now to calculate the velocity, mass is given 50 kilogram, kinetic energy is given 625, then velocity you have to calculate. So kinetic energy, we know that kinetic energy equals to half mv square. Formula. Kinetic energy is given here 625. You put this value in kinetic energy equals to half into mass is given 50 into v square. So 2 ones are 2, cancel it here. 2 25s are 50. Then 625 equals to 1 into 25 will be 25 v square. Okay. Then v square you have to calculate. 625 you have to divide by 25. So 5 5s are 25. 5 125s are 625. Then 5 ones are 5. 5 25s are 125. So v square equals to 25. So v square means you have to find the square root, since you have to find the velocity. Okay. So to calculate v, so v square equals to 25. So v equals to under root square root of 25. So square root of 25 will be 5. So therefore velocity equals to 5 meter per second. The next question is there, you have to calculate the potential energy. Now question number 3. Mass is given 2 kilogram, height is given 10 meter. Acceleration due to gravity g is given 9.8 meter per second square, which is mentioned in your question itself. So potential energy you have to calculate. Pe equals to mgh. So m is given 2 and g equals to 9.8 into 9.8 into height is given 10. So 2 into 98 upon 10. Remove the decimal here. 98 upon 10 into 10. 10 cancels here. So 2 into 98 will be 196 joule. So question number 4 is again it will be different. Okay. Now you have to find the ratio of the kinetic energy of the two bodies here. Okay, the two bodies are here, and these two bodies are having the same mass, and the velocities are different. Okay. Let us consider our two bodies as A and B. Okay. So the mass of A, M, is m1. Let us consider mass of A is m1, and mass of these will also be m1 because they are having the same mass. Velocity is v. Velocity of A is v. Velocity of B is 3v. 3 times v. Then kinetic energy equals to half mv square. Here also half mv square. Apply the formula here. Then half into, substitute the value of mass. Mass is given m1. So m1 velocity is v whole square. Here also half m1, but velocity is given here 3v. So 3v whole square. Half into m1 v square, multiply this, half into m1 3 square means 9, v square means v square, so 9v square. When you multiply this, because 3v whole square means 3v into 3v, we have to multiply 2 times here, so it becomes 9v square. Then multiply here, kinetic energy equals to m1 v square divided by 2. Here also m1 9v square divided by 9m1 v square divided by 2. Now what to do is that kinetic energy, you have to find the ratio. So to find the ratio, you have to write this m1 v square upon 2 divided by 9m1 v square divided by 2. This is the condition, okay? Because there is no space here, so I have written it directly. So m1 v square divided by 2 divided by upon 9m1 v square divided by 2. So what will happen? That 2 will reciprocal. So m1 v square divided by 2 and this 2 will go up. Okay, divided by 9m1 v square. So 2 cancels here, m1 also cancels, v square also cancels. So on the numerator side there is nothing, so you will consider as 1. Denominator 9 is remaining here, so 1 upon 9. Therefore kinetic energy equals to 1 is to 9. So the kinetic energy of the two bodies having the same mass but moving with the different velocities is 9. 1 is to 9. So please follow that another question here, question number 4 and 5. These are very easy. The 4 I have done there. The last question is the question number 5. A body does 60 joule of work in 10 seconds. Calculate its power. So to calculate power, what to do? Work done is given how much? 60 joule. This is question number 5. Work done is given 60 joule. Okay. Time is given 10 seconds. Okay, 10 seconds. You have to calculate the power. The last one is calculate the power. So power equals to work done divided by time. This is the formula. Then work done is given here 60. Time is given here 10. So 10 ones are 10. 10 6 are 60 equals to 6 watt. So the power is 6 watt. Instead of writing W A T T watt, you can write calculator W. So that that is the symbol of power. So the power will be 6 watt. Okay, so these are the numericals of the chapter. So we have come to the end of this chapter, and the 3 chapters I have given you for your final term examination, and all the 3 chapters I have explained it. Please go to the video properly, and all the question and answers which I have sent you in PDF, please write it down and prepare well for your exams. Best of luck for your coming final term exams. Thank you.